Welcome back, folks. We're going to do another problem with the mesh shortcut. Oh, let's scroll up a little bit here. We want to find the mesh currents for this problem. Now, we've already worked this problem before. We're going to do it a lot quicker this time. There's going to be a lot of scrolling. I do apologize for that. Only because the circuit's so big and I got to fit the matrix in there. But we're taking the same approach. We got to make a plan. It looks like there's no current supplies. We're not going to write any KCLs. If we're not going to write any KCLs, then it's all KVLs. So let's, I usually don't write these in, but I find that, my goal here isn't just to analyze the circuit, it's to get you to analyze the circuit without me. So I do think it's worthwhile to say, okay, we're writing a KVL for I1, I2, and I3, remembering which columns correspond to which coefficients. I1 and I2 and I3 on the top there. And now let's just work our way through. What is I1 touched by itself, since those two are the same? 9K and 6K are 15K. Don't forget the prefix. Good way to screw up. What does I1 share with I2? It looks like this 6K over here, so it's going to be negative 6K. All right, and then what does I1 share with I3? Now, it shares the voltage supply, but that's not our passive component, right? So it doesn't share anything as far as I'm concerned. The 6 volt is going to show up over here. I'm going to go up across the 6 volt as I go clockwise. So that one's done. Looking at I2, what does I2 share with I1? It shares the 6K. Okay. What does I2 touch by itself? 6K, 6K, and 12K. So that's going to be positive 24K. And then what does I2 share with I3? And it's peeking out right here. And it's going to be this 6K. So it's going to be negative 6K over here as well. Okay, right-hand side, no voltage supplies in that mesh. So that's 0. Okay. Last one, I3. What does I3 share with I1? Nothing. What does I3 share with I2? This 6K. So let's get those filled in. Okay, no passive component shared there. Negative 6K shared here. And then what does it touch by itself? It looks like we got a 4K and the 6K. So that's going to be positive 10K. Don't forget that voltage supply, right? We're going to cross it again, but we're going to cross it in the opposite direction. So it'll be negative 6. All right. Solve it. Rely on your tool. 15E3, negative 6E3, 0, and 6. Negative 6E3, 24E3, negative 6E3, 0. 0, negative 6E3, 10E3, and negative 6. Okay. And from that, let's see if I can fit this above my head. Yeah, it looks like I can squeeze it in there. 373.3 microamps, negative 66.7 microamps, and negative 640 microamps. Okay, so we got the mesh currents. Even with talking 3 minutes, I can go faster. I go faster when I'm typing it directly in the calculator. Let's go check our previous video. Okay, from the previous video. And hopefully we find that it's right. So I'm going to pull up those notes again. I was better this time, and I prepped it. It looks like this, okay, and you'll notice that we ended up with the same solution for our mesh currents. Okay, things are a little out of order, so it looks like I wrote the equations out of order. As long as each row has an equivalent row down here, you're in good shape. And because of the order of the coefficients, the currents came out being equivalent. Okay. Quicker, not down to 30 seconds. You got to practice that. I can do it. It's a parlor trick, really. Impress your friends whenever they open Elmer's again. You think they'll open Elmer's again? Yay. It's a bit of a parlor trick, but you can do it quickly, and you can do it without too much algebra as well. I don't think we did any algebra other than adding. Okay, got to figure out how to deal with current supplies using the shortcut. That's where we're headed next. Stay tuned, and good luck.